Hello, young people. Part 5 of Unit 2.1 Sunlight Distribution. I've prepared a visual aid for this particular video because I think it might really help. It is a model. We talk about making models and how models can be super complex or they can be super simple or anywhere in between, and this is about as simple as it gets. Took a ball of aluminum foil, or I took some aluminum foil and made a ball and wrapped it around my ballpoint pen here. And the reason I did this is because I wanted to have a little model to show. This is going to be our shiny little Earth right here. It's not very round, and it's a little lumpy. That's okay. And the pen is going to represent the Earth's axis of rotation. So the Earth rotates around its axis of rotation every day, right? Once every day. The sun rises, the sun sets. The Earth is constantly spinning, and as it's spinning, it's going around its orbit. It's going following its orbit around the sun, right? And you see what we're doing here. So now here's the real thing. Here's what I want to show you: is the Earth's axis of rotation is not perpendicular to its orbit. If you laid its orbit on the ground like a big hula hoop, the axis of rotation is not sticking straight up in the air. Okay? If you laid the Earth's orbit on the ground like a flat hula hoop, the Earth's axis of rotation would actually look something like that. And so as the Earth is traveling around the sun, that axis of rotation has a tilt to it. And what that does is if the sun's right here in the winter time, the southern hemisphere is closer to the sun. And then it comes around here, and in the summertime, the northern hemisphere is closer to the sun. That's the reason we have seasons. It's the reason that summer is turning to fall. As a matter of fact, I believe it'll be the first day of fall when these videos are posted. And because the Earth's axis of rotation is tilted, and because annually or seasonally the Earth does not all get the same amount of sunshine, that means that the Earth receives, different parts of the Earth receive different amounts of energy. The amount of light reaching the Earth's surface changes with the seasons. You already knew this. In the summertime, the days are long. In the wintertime, the days are short. Right now, the days are getting shorter. So the equator, y'all know the equator is 0 degrees latitude, the fattest part of the globe. The equator gets the most sun because it doesn't matter really whether the Earth's tilted like this or like this. The equator is always pretty close to the sun, and that means that at the equator, there's a corollary. The North Pole and the South Pole get less solar radiation, less energy from the sun. And so even though we said the Earth as a system is balanced, inputs and outputs are the same, get the same amount coming in as going out. If we look at those individual locations at the equator, it's not balanced. There's more energy coming in than going out. That's why the equator is tropical. That's why it's hot there. And at the poles, there's more energy going out than there is arriving at the Earth. So somehow we have to get energy from the equator to the poles. And there's two main ways that we do this. convection, remember convection? Variations in density. Convection in the ocean drives these giant ocean currents, these global ocean currents. In Finding Nemo, it's what those stoner turtles ride on, right? Those big ocean currents. And so we warm up the water at the equator, and that warm water makes its way toward the cold water in the North and South Pole. That's convection. The other big place that we move warm to cold is in the atmosphere. We warm up the air at the surface, we get convection, which causes warm air to rise and cold air to take its place down below. Have you ever wondered why it is that the wind seems to pick up in the afternoon? It's because in the morning the sun comes up, we get solar radiation reflecting off of the ground, reflecting off of the land and the rocks and the soil and the trees and everything. And through conduction, touching, some of that solar energy warms the surface of the planet. And then through conduction, the surface of the planet warms the atmosphere. The atmosphere expands and rises, and then you get cold air coming in, but it takes part of the day to get that process going. Anyways, just a couple more points about that. There's way more energy stored in the ocean than in the air. Water can store more energy than air can. So most of that process is driven by ocean currents, and indeed some of the air currents are driven by the ocean currents as well. All right, coming up on our last video. See you there.